Well, hello, good afternoon, everybody. Welcome back. Jiu-Jitsu 2000 here today. I'm back. I hope you're doing fantastic out there. In this video today, we have another offering from WattCycle. I'm very excited about this one. This is their 50 amp lithium iron phosphate battery. Now the first thing that we see here is the user manual. Now this user manual corresponds to lots of different batteries, but we're going to be reviewing the 50 amp battery today. Right there at the bottom there is some information for WattCycle. If we open it up, there are some cautions. Now during this section of the video, feel free to pause your screen at any time because I'm going to go through this fairly quickly. Now here's a 100 amp battery, a 200 amp battery. It does give you a product overview of lithium iron phosphate batteries. There is the charge and discharge curve, and it gives you a little diagram of how to connect the battery. And then of course right here, this is all the specifications. So we're going to be on this first column right here of the 12 volt 50 amp batteries. And the main thing that I'm looking for right now is the charging current. It says standard charging current is 10 amp, but you can go up to 50 amps. So that's really the key that I need to know right off the bat. Moving forward, let's take a look here. There are some battery parameters. So very nice. And then of course, charging with your AC DC battery charger. We're going to do that today in this video. And there is some installation environment, preparation, inspection of the battery, lots of information here. Different cable sizing charts so you know what size cable to use, best practice guidelines. These are just nice user manuals. Now right here you can see there is some connection steps if you want to connect 4 batteries in parallel or 4 batteries in a series. That's what you could do there, and then you could connect up to 16 batteries in a series parallel. So 4S, 4P. That's how you would do that. And then of course right here it talks about a lot of the protection systems that comes with the battery. I'll be talking about that a little bit more in the video today. Wide application of uses that you can use a battery like this for. For us, it's going to be more of the off-grid type situation usage. And again, if you need more facts or information, go to WattCycle.com on the internet. There is some warranty information. And then of course, after sales service, how to store the battery, disposal and recycling, and then of course, a packing list of what we can expect to find in this package here today. And then the thank you note from WattCycle. I think that's pretty cool. And that's about it for the user manual. So the next thing that we see here is a package of screws. These are M6 stainless steel screws, and I love that they have the Phillips head on them. So it's cool that they include 4 of them as well. We only need 2 for the battery, so the fact that they include extras is fantastic. Now, without further ado, we're just going to pull this battery straight up out of the box, and as you can see, it was packaged very well. Nice foam protection all the way around the battery, so no problem. And then of course it comes in this plastic, so you don't have to worry about dust or water intrusion on the battery during shipment. I gotta tell you folks, that is a nice looking battery, and as you can see right out of the box, it does come with these little insulators on the terminals so you don't accidentally short circuit. That is a nice looking battery. The form factor is beautiful. Very nice looking battery. It's got the little handle here, this little strap, and then of course there is some information right there on the side of the battery. Again, feel free to pause if you want to read that. I want to take a voltage measurement and see what kind of voltage we have in this battery right out of the box from shipping. So we'll take a look at this. Put it right there, put it right there. 13.31 volts. That's not too bad. We're going to go ahead and get this bad boy charged. It shouldn't take too long because it's already at 13.3. We're going to take these screws out and put them in, and we'll go ahead and hook up the charger. So we'll set those up top. So the dedicated lithium iron phosphate charger that we're going to use today is this one. This is a 20 amp charger. I will plug this in last. So I'm going to take these leads, positive and negative, and I'm just going to connect them to the battery, and then we'll get this charging started. Let's go ahead and get the negative connected. I just put these little ring terminals on here. It makes it nice and secure, just like that. There's the positive, and we'll connect that. And now you can see we have some indicator here, green, but what we're looking for once we plug this in is we want to see this thing charging. So right now we have a red indicator telling us that we're charging, and then when charging is complete, this indicator will turn back to green. So we're just going to let that sit there. Now while I'm charging this battery, I want to talk about some of the specifications of the battery. So the standard charging capacity that this battery likes is a 10 amp lithium iron phosphate charger. However, you can go up to a 50 amp max charger. So this one here is 20 amps, so that is perfect. That's well within the spectrum. Now if you're using a 20 amp charger like this and the battery is fully dead, you could charge this battery in about 2.5 hours. But if you're using a 50 amp charger, you could charge this battery in about an hour. That is absolutely fantastic. This battery does have a pretty nice BMS. This battery is not really heavy. It's a light battery. It only weighs about 11.46 pounds, which if you consider this battery versus a lead acid battery, this thing is like a third the weight, so that's fantastic. The dimensions of the battery, it is 7.68 inches wide, 5.12 inches deep, and it is 6.7 inches tall. These terminal bolts are M6 bolts. The rated voltage of this battery, as you can see here, it says 12 volt, but it's actually 12.8 volt. Your standard charging voltage that you would need for this battery, that is 14.6 volts. The shipping voltage, as we saw, was somewhere between 12.8 volts and 13.5 volts. So we saw earlier that we were around 13.3 volts. So that battery ships about half capacity. Now this battery does have a 6,000 cycle rating at 80% depth of discharge. That is fantastic. This battery is IPX7 dust and waterproof. So that's fantastic. Your storage temperature for this battery is anywhere from 32 degrees all the way up to 140 degrees Fahrenheit. Now when you run 4 of these batteries in parallel, you'll get a 12 volt battery bank of 200 amp hour. And if you run 4 of these in a series, you'll get a 48 volt battery bank at 50 amp hour. And then when you run all 16 in that 4 series 4 parallel configuration, you will get a 48 volt 200 amp hour battery bank. When we talk about the overcharge protection voltage on this battery of 14.6 volts, what that means is if an individual cell voltage exceeds the prescribed threshold during the charging process, the BMS will stop the charging in its entirety. And when it comes to the battery being over discharged, where it's going to protect it from voltage, that's when you drop down to about 9.2 volts. If an individual cell falls below the prescribed threshold during the discharge of the BMS, it will prevent further discharge of the battery voltage until it reaches above 10.8 volts. And then when that happens, the battery will automatically reconnect itself after 15 seconds. Now you're charging high temperature protection. The BMS will not allow a discharging current if the internal temperature of the battery has reached 149 degrees Fahrenheit or 65 degrees centigrade. Now when it comes to the discharging high temperature protection of this battery, The BMS will not allow a discharging current if the internal temperature of the battery has reached 158 degrees Fahrenheit or 70 degrees centigrade. Now, low temperature charging and discharging current, so the BMS will not allow a charging current under 32 degrees Fahrenheit or 0 degrees centigrade, but it will continue to discharge down to -4 degrees or -20 degrees centigrade. That is fantastic. You also have the overcurrent and short circuit discharge protection. So if the overcurrent or short circuit protection is tripped, the BMS will shut down the battery and will remain disconnected until you remove the battery cables. When the battery cables are disconnected, they suggest that you take the battery voltage and check it with a voltmeter, and if it reads above 10.8 volts, go ahead and reconnect the battery cables. If you're unsuccessful in obtaining a voltage above 10.8 volts, they say that you need to contact the WattCycle Technical Customer Support Team, service@wattcycle.com. Now, cell balancing is pretty important when you're going to do any of these batteries in configuration. Say you're going to put 4 in parallel or 4 in a series, you want to make sure that you charge each one individually. A passive balancing process is activated by the BMS at the top of each charge cycle. When the battery voltage exceeds 14.1 volts, this ensures that all the cells remain in the same state of charge, which helps this battery pack the performance. Now, some of the applications that you could use a battery like this for are, maybe you're going to put it in an RV or a travel trailer. Maybe you're going to put it on a boat, use it for a fish finder or a trolling motor. You could use it for solar energy storage. Maybe you're on a job site and you want to run power tools or charge batteries for your cordless tools. You can also use a battery like this to replace a lead acid battery. Maybe you're using it for home energy storage or a power wall. That's pretty cool. You could put an inverter, put a charge controller, put a panel outside, and have free electricity. Maybe you're on a boat or you're doing nautical applications, fishing, boating, electronics. It works good for that, ice fishing. If you're going to run a recreational vehicle, or, like I said earlier, in my situation, the off-grid lifestyle. A battery like this packs way more punch than you might think. These things are awesome. Deep circulation applications. Maybe you want to set up a communication system for ham radios or something like that. Now, what do you do if the battery gets to a voltage of none? Don't worry. If you put the multimeter on the battery and it's showing 0 voltage, this battery is probably under some BMS protection. When that happens, you want to disconnect the battery from the load, test the battery voltage again, and if the voltage is more than 10.8 volts, reconnect the battery. If the voltage is lower than 10.8, I would personally suggest connecting it to a charger. And then, of course, if you need to contact, you can go to service@wattcycle.com. And now we can see that charging is complete. We have a green indicator light down there. So let's go ahead and take our multimeter one more time. See what kind of voltage we have here. 14.43. That is fantastic. That's a very good, well-charged battery. I always like it when a battery charges to a higher voltage. It makes me feel confident about that battery. So let's go ahead and take these screws out and we'll put them right back in. And then we will connect a power inverter and we'll get to testing. We'll see how this goes. And the power inverter that we're going to use today is this Ampeak 1000 watt power inverter. So I just got alligator clamps here on this thing. Now we can push this button and turn on our power inverter. From here we can start testing. So today we're going to take a look at this small 3-quart pressure cooker. This thing should pull somewhere in the neighborhood of about 600 watts. So we'll put the lid on and we will go ahead and hit pressure cook. And let's see how this works. There you can see our voltage drop. We're pulling 770 watts, 780 watts. And we're right now, the heating element is getting hot on here. And then once it comes up to pressure, the wattage will drop. So testing the battery cables to make sure they're not getting hot or warm or anything like that. And so far, we can see that the battery's running just fine. And as you can see, we are now up to pressure. Let me fill these wires, and they are warm to the touch. They're not hot, but you can see that the battery voltage went back up and we stopped drawing wattage. That's because this thing is up to pressure now, so it's not drawing anything. So I think that is fantastic. The battery voltage still being at 13.1. We can go ahead and cancel this test, and I want to try another test, and I think this one draws like maybe 500 or 600 watts. It does the same thing. It's a little hot plate, so we'll turn this bad boy on. We'll put the pan right back on. We'll add a little water so we don't burn, and you can see that we're pulling 530 watts. It's definitely testing the system very well. And as you can see, the water is now starting to boil. So everything is working well. The battery is doing a fantastic job. Let me go ahead and fill these cables. They're warm to the touch, but they're not hot. So I like the way this thing performs. Let me go ahead and shut this off. And let's see what happens. We're drawing 0 watts now, and we still have 13.1 volts in our battery. Now this battery has 640 watt hours of capacity, so if I was going to continue to run this little cooker, which pulls roughly 500 watts, I could run this cooker for 1.28 hours on that battery. That is a fantastic amount of runtime, considering that this is a constant draw. Now once this thing gets up to temperature, it does kick off and on as needed, but we can clearly see that the battery is working very well. So if we wanted to run our evaporative cooler that pulls about 45 watts, this little battery would run that load for over 14 hours. That is fantastic performance for such a small battery. Well folks, that's about all I have for you today in this video. As you could see, this battery performed very well. If you're interested in one of these batteries, I will put a link in the description box down below where you can get in touch with WattCycle. They work very good. The lifespan of these lithium iron phosphate batteries, they speak for themselves. When you compare these versus a lead acid battery, there is no comparison. These are so much lighter, so much smaller. You can take the depth of discharge much further down than you can on lead acid, and the amount of cycles that you get out of these is just fantastic. They're not going to produce any off-gassing, so if you want to put this in an RV, in your car, anything like that, you will not have a problem doing so. So with all that being said, folks, thank you so much for watching. I hope you enjoyed this video. Please feel free to leave your comments down below, like this video, share this video, and until next time, we'll see you on the next one. Bye for now, everybody.